In this video, we'll do an example of trigonometric substitution where we have an integral containing a squared plus x squared. So we're to evaluate the integral of dx over 1 plus x squared, that quantity squared. So we have the form, like I was saying, the a squared plus x squared, where our a is equal to 1 in this case, because it would be 1 squared plus x squared. So what we're going to do is we're going to let x equals to a times tangent of theta, which would just be 1 times tangent of theta, so x will be just tangent of theta. Then dx will equal to secant squared of theta d theta. So doing our substitution, we have that, like I said, the original integral, the integral of dx over 1 plus x squared, that quantity squared, we'd have that's equal to the integral of, instead of dx, that would be secant squared of theta d theta, all over, instead of the 1 plus x squared inside the parentheses, this will be the quantity 1 plus tangent squared of theta, that quantity squared, which is equal to the integral of secant squared of theta d theta, all over, well, 1 plus tangent squared of theta, that's equal to secant squared of theta. So this would be secant squared of theta, that's squared. So this would equal to, canceling out two of the secant of thetas on top and bottom, we'd have the integral of d theta over secant squared of theta, which would be the same thing as the integral of cosine squared of theta d theta. Now remember, to do an integral of a trigonometric function where it's cosine to an even power, what we often do is use the double angle formula that says that cosine squared of theta is equal to 1 plus cosine of 2 theta all over 2. So we're going to substitute that in for the cosine squared of theta. So this gives us the integral of the quantity 1 plus cosine of 2 theta all over 2 d theta, which is the same thing as rewriting it as the integral of just breaking up that into two fractions. So this would be the integral of the quantity 1/2 plus 1/2 cosine of 2 theta d theta. And now the integral of the 1/2 d theta, that would just be 1/2 theta. And then to find the integral of the 1/2 cosine of 2 theta d theta, you do a substitution where you let u equal to 2 theta. And when you do that, what you'll end up getting is that integral will equal to plus 1/4 sine of 2 theta, and then we have the plus c. So we've now integrated it. So remember, what you next need to do is to do a back substitutions, because we need to rewrite this in terms of x, not in terms of theta. And to do that, we often use a drawing of a right triangle, where we look at our original substitution where we said that tangent of theta was equal to x. So if we let theta be this angle, then x is the same thing as x over 1. So if tangent of theta is equal to x over 1, that's, again, remember, that's our opposite over adjacent. So the side opposite of theta would have length x. The side adjacent to it would have length 1. And using the Pythagorean theorem, that the length of the hypotenuse would then be 1 plus x squared. So what we next need, though, is we don't just need sine of theta, we need what is sine of 2 theta. Now what we're going to do is use the identity that sine of 2 theta is equal to 2 sine of theta cosine of theta, which in this case would be 2 times, well, sine of theta, that would be what, the opposite over hypotenuse, so that would be x over that square root of 1 plus x squared. Cosine of theta would be adjacent over hypotenuse, so that would be 1 over the square root of 1 plus x squared. So the sine of 2 theta, simplifying this all out, this would be 2x over the square root of 1 plus x squared times the square root of 1 plus x squared. That would just be 1 plus x squared. So the sine of 2 theta is 2x over 1 plus x squared. So plugging this all in, we know that, let's see, that this original integral of dx over the quantity 1 plus x squared, that quantity squared, is equal to 1/2 of theta. Now one thing to note is that if tangent of theta was equal to x, then theta would equal to tangent inverse of x. So this integral is equal to 1/2 of tangent inverse of x plus, now instead of the sine of 2 theta, this would be plus 2x over 1 plus x squared, all of that plus c.